Hi, I'm Kevin Leyton-Brown, and I'm here to tell you about a new graduate course in our department called Modeling Human Strategic Behavior. This course is going to live somewhere at the boundary between artificial intelligence, machine learning, and microeconomic theory. It's going to think about how to build machine learning models that can be used to predict how people really behave in strategic situations. The strategic situations are those where people have opposing or distinct interests, and they have to reason about how other people will behave to decide on a good course of action for themselves. The course will be remotely co-taught by James Wright from the University of Alberta. We're going to hold classes over Zoom to permit interaction with University of Alberta students, and we'll also meet in person at UBC. The course doesn't have formal prerequisites, but I recommend that you understand some background in machine learning in particular. It might be helpful if you know something about microeconomics and game theory, but that's not necessary. Roughly, the course is going to proceed as follows. It'll be centered around a group project that you'll do throughout the course, where you're going to form a small group and identify a strategic domain that interests all of you, hopefully related to your existing research interests. We're going to begin by trying to understand what we mean by a strategic situation, which, roughly speaking, is a setting in which you have multiple self-interested actors, and the way they feel about the state of the world depends not just on the choices they make, but on the choices that other actors make as well. And we're going to think about a variety of different kinds of models of these settings that have been studied in the classical game theory literature, where people make simultaneous moves, sequential moves, where they have perfect or imperfect information, and where the games are repeated or not. So the first unit is one where we're just going to come up with these domains that you're going to study and understand what makes a domain appropriate to think about using game theory or not. In our second unit, we're going to think about what classical game theory has to say about these kinds of problems. So we're going to start from the classical game theoretic solution concepts like Nash equilibrium, dominant strategies, minimax, and we're going to understand how to apply these ideas across these game formalisms that I just told you about: normal form games, extensive form games, and so on. And then your second assignment will be to try to come up with some game models for your own domain and to analyze them using these formalisms to understand what classical game theory would tell you about your domains. We'll move on to thinking about modeling human behavior, because it turns out that despite the beauty of classical game theory, it doesn't always do a good job of describing the way real people behave. So here we're going to think about other models that have come mostly out of the behavioral game theory literature in economics, and try to understand how they describe human behavior in these kinds of settings. Here we're also going to think about experiment design, how you would actually go about getting training data from humans, make sure this data is representative of your setting, fit models to it, and make sure that you fit the models appropriately. Your assignment in this section is going to involve playing the games that your other groups each made to gather training data, using these to fit models and arguing what's appropriate in your domain. At this point, we'll have a midterm in the class that will test everything that you've learned from these three settings, and we'll be done with assignments. Now you'll move on to the last part of the course, where in lectures, James and I will survey some advanced topics on more cutting-edge research on modeling human behavior that combine both behavioral game theory and machine learning. We might talk about things like no-regret learning, using deep learning to play large zero-sum games like Go or poker, computational approaches to reasoning about large general-sum games, more sophisticated behavioral game theory refinements, such as those that think about fancier models of non-strategic agents and behavioral models of finance. And at the end of the course, you'll hand in not a project that tries to describe finished work, but a hypothetical thesis proposal that will put forward what a research program might usefully be in your chosen domain. And like a real thesis proposal, you'll talk about why the problem is important, you'll survey related literature, you'll give whatever initial results you have, and you'll describe promising avenues for future exploration. And along the way, you'll get a sense of how to do a thesis proposal, which many of you will need in the years ahead. It's going to be an exciting class, and I look forward to having your participation.